This is the beginning of section 1.6, page 21. We'll take a look at linear regression and then some quadratic regression. But before we do that, we have to talk about what regression is. This is a term that describes a way to measure the relationship between two variables. And most regression models begin with a scatter plot that's created from collected data. There are several possible types of trends that you could have, but we're just going to focus on trends that are linear or quadratic. So the first thing we're going to do is we're going to be going to Desmos and we're going to start graphing. So I'm actually going to show you this, and even though right here it talks about Schoology, we are not using Schoology anymore. So I'm actually just going to block that out and take you over to the computer. In the virtual classroom for this class, there are two links that will take you to Desmos. One link is set up for if you think the trend is going to be a line, and one is set up for the trend being quadratic. So I'm just going to show you really quickly that if you click on this, the benefit of doing it this way is that you don't have to try to type this in to Desmos. It's already typed in for you. So if you're going into Desmos quadratic, it's already set up. All you have to do is put your data in. So that's the benefit of that. So going back to the notes, I did write on here what it is that you'd be typing into Desmos, but I am just going to kind of have that there so that you have the information, but you don't have to worry about having to type that in because you have those buttons that we have in Desmos. So let's look at linear regression. If you did choose to type this in, that's amazing. Just remember that in order for you to see anything on your graph or see a trend, you have to put data in the tables. Once you put data in the table, you'll see information start to pop up in the row that has this typed into it. The things that we're looking for if you're doing a linear regression is the slope and the y-intercept. So this is when the computer is giving you a line of best fit, a trend line in the form of slope-intercept form. So like right here, the linear model is y equals, and then this is the slope they gave us, and this is the y-intercept. Just as a little side note, r and r squared are used to measure different statistical things, and I just kind of put a quick little explanation here if you're interested in looking at that further, but we're not going to be looking at that for this section. Okay. Then as a quickie also, quadratic regression just means that your data fits more of a curved trend, either a smile or a frown, but everything works exactly the same. You put your data in the two columns, and then here you have the form for a quadratic equation, and they give you the number to plug into A, B, and C so that you can give what the equation of the model is. And so in this case, yeah, they are ugly numbers, but it works. So that's a thing. Next page. We have to do some examples. So this first example is actually asking you if the data is linear or quadratic. So I want to show you how to deal with that. First of all, this is data that's collected about students and how long they study and the relationship it has on the grades on their test. I'm just going to take a shot in the dark here and put this in to a linear regression model. So back here at the table, I'm going to go back into our classroom, pick linear regression, and I'm just going to put in here all of the amounts, all the data amounts. So here are my values all in my table. If I scroll down, I now see all the information. Again, this is set up for linear. I'm just going to zoom out a little bit and see if this actually looks like linear. Now, I want to have a perfect window. Right now, my window is not really a perfect window. I can go up to the corner and I can go to the wrench, and I can actually put values for the x and the y axis. the best way to do that is to look at the range of values here. If I go from 0 to like 6, I should have all of those values encompassed in there. So I'm going to do that, 0 to 6. And then for my y values, anywhere between, I'm going to go a little bit before 60, so I'll put 50 to 100. That's probably a good range of values to look at people's scores on their exams. Okay, so this is my perfect window. And yes, this does look like, if you had to pick a trend line, it does look linear. It does not look like a curve. Notice that this is not making a perfect line. These dots are not collinear. And if you are dealing with real data, your dots probably should not be collinear. They should look like this. If you have one that's way off in the distance, we call that an outlier. I don't really have many outliers here, but this looks good. If you're looking back at the notes, there are some questions that need to be answered. The first one is whether or not this is linear or quadratic. So we're going to go ahead and do linear. Writing the equation, we have to look at the information that we got in the window. It gives me an m value of 5.44684. So I'm going to start with y equals 5.44684x plus the b value they gave me, which is 69.756. Then it asks, if you study for 3 hours, what grade would you expect to get? Well, let me tell you what. Remember that hours is represented by x. So if I go back to my window and I say x equals 3, I can just look at the intersection point for that. 3 hours, the prediction is you'll get an 86. So I'm going to go ahead in my notes and write 86. Okay, that's our first example. Let's look at the second one. The data set is collected by measuring the arm span and the height of students in inches to see if there is a relationship there. The first thing it asks is linear or quadratic. Who knows? Sometimes the best way to go about things is to just test it out in linear first to see what it looks like. And if it doesn't, you can just take that table and paste it into the quadratic model and see if it works. So I'm going to go back to the classroom and go to linear. This gives me a nice fresh thing to work with. I don't have to erase anything. And I'm going to put this information in. After I have this information in, I'm also going to check and make sure my window works for my data. So x values look like they range from 60 to 71. So I'm just going to give myself a little bit of room here and go from 60 to like 73. And the y values look like they range anywhere between 60 and 72. So again, I'm just going to do the same, 60 to 73. So I can see all my dots. So I have to move all these things around so I can see if this looks like it's linear. Again, it does. So in my notes, I'm going to write linear. Write the equation of the curve of best fit. I'm going to have to look at the information. My slope is 1.1936 and my y-intercept is negative 13.0233. So I will write that equation into my notes. Lastly, asking us what is the expected height of a person with an arm span of 66 inches. And remember that on my table, the arm span is X and the height is Y, and they're saying arm span of 66. So I'm going to write X equals 66 and see what I get for Y, and it looks like 65.754 inches tall. Fun times. Let's look at this last question here. This table displays temperature recorded during a 10-hour winter snowstorm. Does it have a linear or quadratic relationship? I'm going to go back. I'm going to get a fresh linear one just to type this in. X is time since the snowstorm started in hours. So it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the inches, we'll put it in real quick. Okay, and then I'm going to go right to my wrench and I'm going to go from 0 to 11 for my x values, and for my y values, I'm going to go from 5 to 30. How about that? See if there's a linear relationship here. Well, look at this. This is definitely not a linear relationship. This looks like a quadratic. So I'm actually going to take my information and I'm going to, this is going to seem kind of strange, but instead of taking my table out, I'm actually going to change this. I'm going to do that by opening in a separate window the quadratic formula so that I can copy it and go back into this window and paste it in. That's the easiest way. Then it gives me a curve of best fit. This is very accurate. A, B, and C are given to me. So the first thing I do is I say quadratic relationship. The curve is 0.742x squared minus 8.12x plus 35.07. And then they want us to figure out how much snow should be happening at 12 hours. I'm going to write x equals 12 so that I can see where these, according to my model, are going to meet. And 44.5, actually 44.6 inches. That would be interesting. It's happened, I'm sure. Okay, so this is us using Desmos to help find a linear or quadratic model that fits a given data set.